Okay, everybody, it's 12 o'clock on the dot, so let's go ahead and get our meeting started. I'd like to say on behalf of Soil and Water Conservation District and CWLP, thanks everybody for joining. And welcome to our very first webinar in the Lunch and Learn series, which is provided by CWLP and the Soil and Water Conservation District as part of the IAPA 319 grant and the Lake Springfield Watershed RCPP. So the grant and the NRCS RCPP funding pool work to provide education and outreach, as well as producer funding for on-the-ground conservation efforts in order to improve water quality here in our Lake Springfield watershed. If you'd like to be on the Lake Springfield watershed emailing list so you can receive information on funding and outreach events, please contact one of those four contacts at the beginning of the chat box, either the Soil and Water Conservation District or myself. Our Lunch and Learn webinar series is going to run the second Wednesday of each month, February through November, except for April and October, I believe it is. Our webinars focus on current important topics in agriculture that also pertain to soil health and water quality. And they cover information on agricultural, urban, and stormwater BMPs, current and future carbon market opportunities, solar and wind leasing opportunities, WOTUS permitting updates, conservation considerations to farm leasing, as well as woodland improvement and invasive species control. The Lunch and Learn webinar today is presented by Jean Brokish, and it really gets into the details of best management practices for water quality and soil health. She has decades of experience, so we're really lucky to have her spend her time here with us today to learn more about this topic. Jean is the Midwest Program Manager for the American Farmland Trust, where she provides coordination and management support for the Illinois Sustainable Agricultural Program, as well as support for the Vermilion Headwaters Watershed Group and the Upper Macoupin Watershed Group. She has an agricultural background. She grew up on a dairy farm in Southwest Wisconsin, and she holds a Bachelor of Science in Agronomy from the University of Wisconsin at River Falls, as well as a Master of Science in Soil Science from Purdue University. She also spent 11 years at Oahu Resource Conservation and Development Council, leading conservation and outreach programs and providing oversight for multiple watershed implementation projects, on-farm cover crop research, and building Hawaii's Women Farmer Network. Besides being passionate about her career in agriculture with the AFT, she also enjoys gardening and being outdoors with her family. So that's our brief introduction. And right now, I'd like to just have everybody, if you could, in the chat box, answer a brief question of what your role is. Are you a producer or a farmer? Are you a non-operating landowner? Are you part of a government entity, a farm loan officer or a farm manager, maybe an extension or educator or researcher or just something else? So if you could type that into the chat box. I'll give you a minute and then we'll go ahead and get going with the actual presentation. Thanks, Wes. We have a farmer and landowner. Very good. We have some private consultants. Okay, more agriculture. Okay. And as you guys keep typing, I guess I can just go ahead and hand it over to Jean Brokish while you all start or complete answering the question over here. Jean?
Great. Thanks, Sarah. Can you guys hear me? Good? Can you hear me all right? All right. And I am going to, I'm excited, even though we're a small group, we have a good diversity of perspectives from farmers and landowners and farm advisors. So hoping we can have a good discussion today. I'm going to pull up my slides here and just ask that maybe Sarah, you can give me a thumbs up that it looks all right for you. They look good? Okay, great. So Sarah read my introduction, which actually sounded a lot longer when you read it than what I thought it was on paper. So I'll breeze over that. But I've just been asked to kind of touch on a little bit about best management practices for water quality and soil health, which is a really important topic. Lake Springfield Watershed has a watershed management plan that I will be referencing a little bit. So I'm also curious, I guess, from people on this call, if you're actually engaged with that Lake Springfield Watershed group or not, or if you're a farmer in that watershed. That would be interesting to know as well as we move through these slides. So the first, I have to give a little shout out to American Farmland Trust first. I am the Midwest Program Manager for AFT, which is actually a national organization, and it's often most recognized by its No Farms, No Food bumper sticker. Some of you might have seen that, you know, on trucks or vehicles or tractors around town. And if you're interested, I can send Sarah a bunch of them and she can distribute them to people in the watershed. Our mission really is to, in a nutshell, is to save the land that sustains us. So we do that by one of three ways. First is protecting farmland, you know, looking at some of the kind of the urban sprawl and low density residential developments that are consuming prime farmland. That's a real concern for us as an organization, but it also really is thinking more broadly about farmland and protecting farmland and thinking about, you know, if we're managing it well, we need to manage it well. So promoting those sound farming practices, but we also need to ensure that farmers can access the land and make a living off of it. So by promoting policies and programs and initiatives that can help farmers be profitable and successful. So today, I mentioned already, I've been asked to touch on best management practices for water quality and soil health. So I'm going to kind of just give a little bit of an intro of water quality in Illinois and the broader Mississippi River watershed. Also focus on the water quality in Lake Springfield watershed, a little bit of soil health basics, and then connecting the two by looking at the practices that have those co-benefits that both reduce the nutrients and sediment loss from agricultural land, as well as contribute to soil health. So first, we're going to start by just stating the problem. I think, you know, it's always helpful. You know, I think if in our personal lives or in our professional lives, if we just know what the problem is, sometimes it's easier to start tackling it. So some of us might have a shopping problem or a spending problem or a shoe problem, and some of us might have a drinking problem, or some of us may be addicted to bad TV. You know, some of us might have all three of those things. But in essence, the Mississippi River and the Gulf of Mexico has a nutrient problem. The dark green areas of this map indicate where the majority of the nitrogen, in this case, this is nitrogen. So the darker the areas, that's where more of the nitrogen is coming from, and it's causing challenges throughout the river systems and the Gulf of Mexico. And you can see that while the state boundaries are difficult to see, Illinois is definitely in the middle of the dark green. And if we're being honest, Illinois has a nitrogen problem. Same for phosphorus. If we're looking at phosphorus contributions within the Mississippi River watershed, dark areas again, much of Illinois is in that darker area and contributing higher levels of phosphorus to the watershed. These two maps, you know, coloring is a little different here just because the scale is specific and unique to Illinois. And you can see then within Illinois, the darker areas for nitrogen on the left and phosphorus on the right there. But, you know, for nitrogen, the darker areas are around the northeast. A lot of that wet, flat prairie area, a lot of it is tile drained. And that's where a lot of the nitrogen is coming from. And then phosphorus is spread out a little bit. There's not quite as consistent or obvious of a pattern. There's certainly some watersheds that are contributing more phosphorus than others within Illinois. And I think for context, you know, Illinois is about 7% of the water that, Illinois contributes 7% of the water to the Mississippi River and the Gulf of Mexico, but it contributes 13 to 14% of the nutrients. So it's disproportionately high contributor based on the area within the watershed. And, drilling done, I spent some time yesterday looking through the Lake Springfield Watershed Management Plan and found some of the maps within there. Within the Lake Springfield watershed, there's some areas, the red areas on the map here are identified as impaired waters. So those are waters that are higher concentrations of phosphorus or total suspended solids, which is just another name for, soil particles or mineral particles that are in the water, and aquatic algae and dissolved oxygen. So the Lake Springfield itself, and then Sugar Creek and Lick Creek are polluted. They have higher concentrations than is permitted by EPA. I also put total nitrogen on here. While it wasn't listed in the most recent list of EPA as being impaired water bodies, it has been in the past for nitrogen levels being too high in these water bodies. And one fact that I found within the watershed was that 130,000 tons of sediment is entering Lake Springfield each year. And it's the topsoil, it's the fertile stuff, it's the good stuff that we need to protect and keep in the field so we can grow crops and have productive and profitable farms. So looking at that and thinking about that as like kind of a win for everybody. If we can keep the soil in the field, we're helping the farms and we're also helping the water stay clean. Drilling in a little bit deeper than, within the looking at just the nutrients, the major sources identified for nitrogen and phosphorus within the watershed is cropland. In part, this is a reflection of the fact that the majority of the watershed is agricultural land as well. 74% of the watershed is agricultural land. For nitrogen, 94% of the nitrogen comes from cropland, and some of that is by way of the tiles. And then 87% of the phosphorus is coming from cropland. And a lot of that is related to highly erodible land and gullies, which will make a lot more sense when we look at this. Phosphorus and soil are often go hand in hand. If we can solve the soil problem, we often solve the phosphorus problem. And so similar, this map just shows the sediment contributions within the watershed. And again, 94% is coming from cropland. And here, there's a large sediment contribution coming from a relatively small percentage of the land. And it's the highly erodible lands that are utilized for crop production. And so those are the dark gold areas on the map. They tend to be closer to the stream channels. They are just 6% of all cropped soils, and they're contributing 35% of the sediment. And so if we're prioritizing and really thinking about where we can focus our energies, if we can focus our energies on those highly erodible lands, reduce the soil erosion on those areas, we're going to make them more productive for farming, and we're also going to address the phosphorus problem, a win-win situation. So after we recognize the problem, we often just kind of figure out, where do we want to go? What do we need to do? And so both the nutrient loss reduction strategy and the Lake Springfield Watershed Management Plan have identified goals with eventual targets of 45% reduction in both nitrogen and phosphorus over on the right-hand column here. Those are the overall targets: 45% reduction in N and P, and a 54% reduction for sediment. The nutrient loss reduction strategy for Illinois tends to be the overarching kind of water quality mandate for nitrogen and phosphorus, and the Lake Springfield Watershed Management Plan just adopted those goals. And then the 54% reduction came from the TMDL, the total maximum daily load plan or limit that has been developed for Lake Springfield for sediment. So both of the plans, again, the nutrient loss reduction strategy and the Lake Springfield Watershed Management Plan, have identified priority practices within field and edge of field, and also, some land use changes in maybe some more critical areas And this map or this slide just kind of shows those different buckets. And so if we implement nutrient management and cover crops in the field, we can expect somewhere between a 20 to 30% reduction in nitrogen. Looking at edge of field, those practices, bioreactors, buffers, and wetlands can provide somewhere between 25 and 90% reduction. And then if we're changing all of the landscape to perennial crops, we're going to get a 90% reduction, but we're not advocating for that in any way, shape, or form. It's more looking at those critically eroding areas and figuring out if there's a different land use for some of those. And I don't know if my animation will work here, but I have a little, oh yeah, it does. So there's our little target, you know, the 45% reduction. In this case, we can't do that with just in-field management. You know, if we did nutrient management and cover crops on every field, we would get about 30% reduction in the watershed. And so we do need to incorporate some of those edge of field practices and potentially some of that land use change in the more critical areas, as I mentioned. This slide is just looking at phosphorus then, very similar practices with the nutrient management and the cover crops again. And in this infield, we have added reduced tillage as well. And buffers and wetlands for edge of field. And then we have those perennial crop land use change again on the critical areas with the corresponding reductions shown underneath. And my little magic target here of 45%, again, we're still kind of in the same ballpark. We need to look at both in-field management on a pretty significant scale, and then edge of field practices on areas that are maybe more susceptible to erosion. And the last kind of slide with a similar theme is looking at the TSS, total suspended solids. Similar practices again. We have our cover crops, our reduced tillage, and our grass waterways in the fields. We have our field buffers, filter strips, and then within the Lake Springfield Watershed Management Plan, they identified stream bank erosion as one of the sources. And so we can identify those areas and stabilize the stream banks. And then implementing both perennial crops as well as managed grazing would be an opportunity here. And so here, if our target is 54%, in this case, this is interesting to me because if we were to implement wide scale adoption of these infield practices, we could actually achieve 54% reduction in sediment loss within the watershed. Of course, I don't think we'll get it. So while my little arrow is quite fancy, it really, a lot of, we'd have to include all of the tools in the toolbox here to really achieve what we're looking for. And this slide illustrates that, where different BMPs were identified, or priority practices were identified in the watershed management plan. If those priority practices were implemented, we would achieve a 47% reduction in nitrogen, 51% reduction in phosphorus, and a 56% reduction in sediment. And so we just barely meet our targets in all three of those by following the roadmap set out in the watershed management plan and implementing those practices. And the priority practices really that were elevated in the plan included that reduced tillage, cover crops, and widespread adoption of field borders or filter strips to help capture some of the nutrients and runoff before it enters the water. So this slide just is kind of another simple summary of different practices, again, grouped by the infield practices at the top, the edge of field practices and how they can play a supporting role within the field operations, and then different structural practices here, and then some perennial practice land use change at the bottom. Each column, then we have a column, a check mark, whether it helps to address the nitrogen, phosphorus, or sediment goals. And then on the right, this is something that the watershed management plan and the nutrient loss reduction strategy don't really look at, but I feel they're really important as we communicate the value of conservation to farmers and the public, and we think about what some of those co-benefits are. So a lot of these practices not only reduce nitrogen and phosphorus and sediment, they also can reduce compaction. They can reduce, or they can increase soil organic matter, and they can improve water infiltration, which reduces flooding and runoff. And those benefits are often resonate more with farmers who are out in the field. You can understand, you can feel, you can see the impacts of compaction and low organic matter and poor infiltration. So I just offer that as kind of context for groups and for farmers as you're talking with other farmers about and thinking about and evaluating the benefits of some of the practices that are identified. And so my 3 little arrows just appeared there in terms of emphasizing, again, starting in-field practices are the best first step, and will be the next slides. I have a little bit more information on those practices, as well as field borders, filter strips. Those 2 I kind of lumped together under a heading of buffers. All of those, if you look across the board, have both high levels of nutrient, sediment, and those co-benefits. So just kind of thinking then, taking a half a step back for what is soil health. If we were in person, I would actually ask you to help define this. What is soil health? What does it mean to have a healthy soil? And in this case, the definition is really just the continued capacity of soil to function as a vital living ecosystem that can sustain the plants, the animals, and the humans. So I think it's super helpful to recognize and remember that soil is living. There are organisms living in there and causing it to cycle nutrients and feed our plants and feed our crops and break down dead and decaying material. And all of that is important, that we are supporting that living biome within the soil. And that's really the key to soil health. This wheel, I guess, on the screen is the 4 soil health principles that have been identified and defined as a really great graphic from NRCS again, where we want to maximize the living roots, we want to minimize the disturbance, maximize the soil cover, and we want to maximize that biodiversity. So these are kind of the 4 pillars or the 4 pieces of soil health principles. We know that there are a whole multitude of benefits that come with the implementation of by following the soil health principles. So we have the below ground benefits, and I'm not going to read all of this, but I'm just going to kind of help you understand the arrows. We get an increase in soil organic matter and an increase in carbon sequestration. These are all happening below ground. We're increasing the biodiversity, which is reducing plant stress and reducing the pesticide use. We're increasing nutrient cycling, which means that over time, a lot of farmers have found success that they can actually reduce their fertilizer inputs and not have a yield hit. We're reducing the nitrous oxide emissions, which is one of the most potent greenhouse gases, reducing energy use and reducing water pollution. And a similar list is on the right-hand side. Above ground, we're getting better insulation, reducing evaporation and reducing those temperature extremes. Water infiltration goes up, flooding risk goes down, and then weed suppression goes up by having that consistent cover, which means we're saving herbicide and fuel use as well. And I think as input prices go up, particularly nitrogen prices are skyrocketing right now. If there's ways that we can use, if we can support a healthy soil and we can use the biology of the soil to support our plants and reduce those fertilizer inputs and save some money and make a more profitable farm, I think that is like the ultimate goal of this whole conversation is, and our efforts, and probably the Lake Springfield watershed efforts too, is to just make sure that we're having profitable farms that are also benefiting the environment. So here's the same 4 soil health principles in the wheel, but in this case we have different best management practices that are part of a soil health management system. So there's, again, a long laundry list here. And I put little arrows again by the 4 that I was going to emphasize. We have cover crop buffers, which are both field strips and field borders. And then the no-till, reduced till, and nutrient management. But those aren't the only practices. You know, there is agroforestry, there's rotational grazing, you could do mulching, IPM, those kinds of things are all included in a soil health system. So just, this is really just kind of 101 for farmers in the audience. Probably all stuff you're familiar with, but it's just helpful again to kind of reiterate and think about these practices. So looking at cover crops, just a basic definition, they're crops grown during a time of year when we wouldn't normally plant anything, such as during winter or summer fallow periods in row crop operations. So on the left, we have a cover crop of cereal rye. And on the right, there's the bare soil that has been pretty intensively tilled. You know, maybe that's fallow period, or maybe this is right before planting and they've plowed it or chisel plowed and tilled it to be prepared for the planting season. The benefits of the cover crops is we keep soil covered and in place. We increase that soil organic matter, which increases the aggregation or the ability of soil to clump together into stable aggregates or stable groups. We feed that soil biology, which helps with the nutrient cycling. So I just listed those, but then I also provided, you know, those 3 arrows at the bottom again to just really highlight that cover crops have potential to reduce nitrogen loss by 30%, to reduce phosphorus loss by 30%, and to reduce that sediment by 40%. So real direct connections. By implementing these practices, we can actually help achieve those goals. This slide, again, just kind of emphasizes in a different way some of the above ground benefits of cover crops. With the soil temperature and moisture regulation, we reduce the soil loss from water, which we talked about, but also from wind, particularly in the wintertime. I was driving through over towards the Quad Cities, and I saw a lot of snert a few weeks ago, you know, where we don't think erosion is happening, but if it's dry and cold and the soils are bare, we can get a lot of the soil moving, and we see it on the snowbanks along the roadside there. If we have a cover crop growing, much less exposed to the wind, and we don't lose as much of that through wind erosion. And then again, the weed suppression. This is another thing that I like to think about and talk more with farmers about. You know, herbicide resistant weeds are becoming more and more of a problem, and utilizing cover crops as a way to prevent those weeds from even growing or minimizing the ability for those weeds to take over your field is a real benefit. And then below ground, we have similar things where the roots of the cover crop are improving the soil structure. It's increasing the biodiversity, and then we're getting better nutrient cycling there. The next conservation practice, looking at no-till and strip-till, again, it's just planting the crops without tilling the soil or minimally tilling the soil. So we have our little inset, we have that intensively tilled field, and then the larger picture there is strip-tilled corn. And so you could plant soybeans into corn residue without any tillage, which is fairly common across Illinois. And then strip-till corn is gaining more ground and interest among farmers, where you're just tilling a narrow band and then planting within that strip the following year. Here's an image of soybeans in no-till corn residue. And so the benefits there, we're keeping the soil covered, we're increasing that soil organic matter, increasing the soil aggregation, and reducing fuel costs. Less tractor, less horsepower, less fuel goes into a no-till system versus one that has, 1, 2, or 3 tillage passes. And again, I have my arrows there showing that reduced tillage can reduce nitrogen by 10%, phosphorus by 50%, and sediment by 70%.
Jean, you have about 10 more minutes.
Perfect, great. To maximize the benefits of those reduced tillage systems, you can consider, well, it's really important if you're thinking about shifting to a reduced tillage system, huge factor is just looking at your existing equipment and acknowledging that in many cases it will require some sort of equipment change. And so what is your capacity to do that? The strips, if you're doing strip till, you get the best of both worlds where you kind of get that loose, warm, dry planting bed for corn in the spring, but you're reducing tillage and not disturbing the other area. And then if you do have the ability to put your phosphorus and potassium down with those strips in the fall, farmers are seeing the greatest economic returns under that kind of system. Shifting to our third practice, nutrient management. This is just managing the application of commercial fertilizers and soil organic, whether it's organic or inorganic soil amendments, as a source of plant nutrients. And generally, most people are familiar with the 4 R's of nutrient management. This is a really great way to think about it. It's the right source, the right rate, the right time, and the right place. Just really evaluating the crop need and understanding it, and knowing when the crop is going to use it, and making sure that it's in the field when it's necessary or when it's helpful for the crop, and that we're not over-applying it. A lot of farmers, some years it's cheaper than others, and this year I don't think extra nitrogen is cheap at all, but it's often described as cheap insurance to add just a few extra pounds. But is it really the best way to do that? Is it better to just build your soil health and your soil biology and know that that's going to carry your crops through, versus putting on extra and then having it wash away because it's not in the field anyway? So the benefits of nutrient management, definitely you can increase your return on investment. You can have better plant health when we're really applying the right nutrients. It may increase the soil organic matter, reducing the fuel costs and reducing those nitrous oxide emissions. And again, my little arrows there, 20% reduction for nitrogen loss, 10% reduction for phosphorus, and nutrient management doesn't have any impact on soil loss. Last practice then is buffers, which again, I mentioned both include field borders and filter strips. I just lumped them together under buffers. But essentially a strip of permanent vegetation along the perimeter of a field, which would be a field border, or between the field and a body of water, which would be that filter strip. The benefits of buffers: captures that runoff and reduces sediment and contaminants from entering the waterways. If you look at that little picture, the insert picture in the upper left, there's no opportunity to catch that runoff before it's entering the ditch there. If we had 20 or 30 feet of vegetation there, a lot of that water would be captured, and certainly a lot of the sediment and contaminants that may be in that water would be captured by that filter strip. It also has an opportunity to keep field operations away from the stream bank. I've seen some tractors and implements get precariously close to the edge of the ditch, and sometimes it's a safety benefit actually to just back off a little bit there. And it can also provide habitat, which I'll show on the next slide. But again, just have my little arrows there, 10% reduction in nitrogen, 40% reduction in phosphorus, and a 65% reduction in sediment. And a lot of that, again, is just that we're capturing that sediment and soil before it is actually entering the waterways. To get the most bang for your buck from these buffers, they need to be designed for adequate width based on the field slope. So if you have a steeper area that you're draining before it gets to the water, that buffer needs to be a little bit wider. There is interest and even financial support for utilizing native plants and shrubs in your buffer and thinking about pollinator habitat. That's an added benefit of using buffers. And then for livestock operations, there is also the benefit potentially of using it as a source of forage, particularly in a dry year or an emergency year if you need some additional forage. So I've just touched on 4 of the BMPs that provide those water quality and soil health benefits, but there's more here. And there's actually 45 best management practices listed within the Lake Springfield Watershed Management Plan. So that includes things like for urban areas as well, rain gardens, well decommissioning, shoreline protection, et cetera. And so encourage you to think about lots of opportunities to improve soil health and improve water quality within the watershed and within Illinois at large. And just a few, kind of one quick wrap up slide here. I think it's helpful to recognize that we're all in this together. Reaching the goals of the nutrient loss reduction strategy and that Lake Springfield Watershed Management Plan will require all farms, but not just farmers, urban areas as well, and all residents to implement some sort of management change. I'm speaking from an audience, from a farmer perspective right now, so that's why I'm focusing on agriculture. But there are multiple opportunities to achieve our goals, and those in-field practices are the first step and suitable for most acres. But one size fits all solution does not exist. So every operation will have a different best set of practices based on their landscape, their soil type, and their cropping system. So in other words, I think this is just really helpful for all of us to keep in mind. There's no one practice that's right for every farm, but every farm is right for at least one practice. And that concludes. So just thank you for the opportunity to share information and be part of this Lunch and Learn series. I'm actually going to be back next month too, going a little bit deeper on soil health and talking about some of the carbon and ecosystem market incentives that are available. But with that, I'll stop sharing my screen, and my contact information there if anybody wants to reach out. And I'll turn it over to you, Sarah, to see if there's any questions.
Okay. Amazing, Jean.